So, small update. Finally got the power supply on the main board. Everything's working pretty good, and I'm still waiting for some shift registers and some P&P transistors and whatnot. So, changing transitions on the VFD isn't actually ready yet. But I've been working on the firmware, and well, let's see here. So, every 10 seconds, it'll update the time on the top one. There we go. And so, in order to do that, we use a lot of code. Most of it's for debugging, but a lot of it's for setting up timers and a bunch of other fun jazz. Abusing interrupts, fun stuff like that. But if I do this, and I enable interrupts, or enable debug mode, and I hold, it's going to be hard to do with one hand, shift and right click. If we watch the screen, it'll start spitting out some debug information. So right now it's testing the pulse per second from the RTC. We got 20%, 22% duty cycle, trim values 14. Now it's actually doing interrupt pulses. So these are actual interrupts that are happening. And then we'll say it'll finish, and then it'll start updating up here every 10 seconds. And go. And the only reason I do it every 10 seconds is because VFD tubes only have a couple year lifespan. So if you don't have them on constantly, then they work a lot better. But so quick run through on the code. We're initializing, or we're including wire in RTC. Wires for I2C, enable debug. We're creating a new object for the RTC, some variables and pins, definitions. We're creating an array for the different square waves coming out of the RTC. The initial setup, first we're going to run through init, which is this guy right here. So this initializes everything. This gives us our serial. This returns us back to the top of the terminal window, plus spaces down one. And then all of our printing out, we're enabling RTC, I2C and R2C. Wow, okay, I2C and then the RTC. Setting the pin modes. If the RTC is running or if it's not running, we're going to set it via the time that this was compiled. And I don't have a battery backup on the clock right now, so it's going to set it every time. Then we're going to set the frequency mode that's coming out for 1 Hertz. Then we're going to set up the boost frequency for the SMPS. And so we're setting up timer, I always forget which one, it's timer 2. So we have two timer registers, A and B. And these are setting, these two right here are setting fast PWM mode. And then COM2B1 and COM2AO0 is setting what happens with these two guys. And then TCCR2B is also setting fast PWM mode, and then our prescaler, which is set to 8. And then OCR2A is our frequency. So this is the equation for the frequency. And our prescalers. I think our prescaler's wrong. Yeah, this is all from old equation stuff. And this equation might not work now, I don't know. Anyways, 63, okay. Our CMR is also, it does not equal 7. Our CMR equals like 38 or something like that. So anyways, so this allows us to set our frequency and our duty cycle. And then we're setting the OCR2 pin, which is pin 3 on the Arduino, as an output via DDRD. And then we come back up to the init. We're enabling interrupts with SEI, which some of you should recognize from micros. Then we're going to attach an interrupt to int0, which is Arduino pin 2. So remember, all the pins start from, it skips reset, which is pin 1, and then pin 2 is actually pin 0, pin 3 is pin 2, or pin 1, and whatnot, and so forth. So if we're in debug mode, we're going to go to interrupt test. And so our interrupt test is interrupt test is right here. So for every pulse coming into the interrupt, we're going to write a star, which is these guys right here, and we're going to do 10 of them essentially. And so once we get to 10, then we're going to say it was successful, and then we're going to go back up to the top of the terminal window, and then we're going to detach the interrupt and then reattach it to interrupt update, which is this guy right here. And all this does is every time the pulse goes high, it increments PPS count +1. And then we go back up here, and then let's see here, avoiding it, loop. Okay, and then so we're done with setup. We pop out of setup and come in here to the loop. If we're in debug mode and PPS count is equal to 10, we're going to go to internal update, and same if we're not in debug mode, which was the first mode I showed you. So internal update is we're going to map the analog, the trim pot. We're going to map it to 50, and then of course we'll spit out the value of it. This is all information that's all on the top right here. So you have trim value is 14, duty cycle is 22, RTC mode is square wave 1 Hertz, time, date, whatnot. So that's all inside this internal update. You see here our duty cycle is the OCR2B register times 100 as a scalar divided by OCR2A. That'll give us our duty cycle, which is actually pretty spot on. Let's see here. Oh yeah, we're grabbing the date and time from the RTC, reading the pin mode, and this is not very elegant code. I've actually rewritten this firmware twice so far. I know I should be doing my homework, but I am. So, well, I'm doing my homework on the side of doing this and working and whatnot. So anyways, so we're going to print out the year, month, day, hour, minute, and second, and this is all in 24-hour. So I have to convert this to 12-hour. Then we're going to clear the terminal screen and set PPS count back to 0, and then go back up. Our test, we're doing essentially the same thing. We're checking the trim pot, calculating duty cycle. This guy is actually supposed to be 8. And we can rerun that and see if the boost frequency comes out, because it's saying it's like 900 or 300 or 39k hertz, which is supposed to be 31k hertz. Otherwise we're going to get some weird efficiencies. So let's go ahead and rerun this and see what it says. So right here it says it's 3906. Let's see if it comes out 31. Yep, 31250. That's exactly what we want. And then this is what you were saying. This guy is just counting the pulses coming in from the RTC, so this isn't part of the interrupt, although it is on the interrupt pin. Interrupts are enabled inside of this area. So yeah, and then that's pretty much it. And so far that's the firmware. Oh, and then we have this, which is shift out, which is it's actually on the Arduino form. It's used to shift information out to 74HC 595s. Makes it a lot easier when you already have something pre-built. And over here I'd gotten the legend for, this is all out of the data sheet, and this is all the functions for the 595 and what happens to it and whatnot. And then these are all of the numbers from 0 to 9 on the VFD display. And this is how I map the VFD display. And this is the old firmware, so this started getting really unruly and nasty looking, and I didn't like it, so I redid it. Anyways, so it's a quick little update. If we go ahead and I'll just show you the real-time update of this thing. So if we go ahead and just set this to, I don't know, let's just do 1. And shift. Oh man, It's hard doing it with one hand. This video is going to be like 2 gigs. Alright, so we're going to re-upload that. And then, I don't know how well you can see it because this screen is weird. So the duty cycle set at 22. I just gotta wait for it to get back to the top, and then you can see the duty cycle will change. I should have hooked up the O-scope so we could see that they were pretty well on as well. But, okay, so duty cycle, if you watch the duty cycle, it'll change. It's kind of hard to see. It's 31, 34, 44. It only goes up to, I think, 70. Yeah, 79. And then we can bring it back down. So, yeah, that's pretty sweet. Anyways, quick little update. Well, not so quick, I guess. Yeah, everything's working. Once I get all the rest of the parts, I'll finish building it and do a longer video, or maybe a couple part videos. Anyways, take her easy.